Hi folks, we're going to take a look at page 263, number 7. So they give us this function here, which is a combination of exponential functions, and they want us to prove that the derivative of the function is equal to 1 minus that function squared. Okay, so I'd say the first place to start is let's find the derivative of that function, in other words, the left-hand side of this equality that we're trying to prove. Okay, so here let's find dy dx. Okay, so here we're definitely going to be using the quotient rule, and in finding the individual derivatives, because I have e to the 2x, we'll be using the chain rule. Okay, so let's take quotient rule here. So the derivative of the numerator, well, we know the derivative of 1 is just going to be 0, so we're just dealing with this portion here. Okay, so our 2x is like our u, so the derivative of e to the u is just e to the u, so e to the 2x, times the derivative of u, which is just 2. Okay, and as we said, derivative of negative 1 is just 0. Okay, so we multiply that by the denominator function, e to the 2x plus 1, okay, minus the numerator function, e to the 2x minus 1, times the derivative of the denominator function. We see that it's going to be the exact same derivative as the numerator function, because here the only difference is the plus 1 and the derivative of that is 0. Okay, so this is just going to be e to the 2x times 2. Okay, and all this is over e to the 2x plus 1 squared. Okay, so since we actually have to work with this expression, we want to show that it's equal to something else, I think we should simplify here. So again, a trick we've seen is to look for as many common factors as you can, and we see we've got a few things here because they both have the common factor of 2 and they both have a common factor of e to the 2x. So I'll take that out, 2 times e to the 2x, and what we're left with here is we're left with e to the 2x plus 1, okay, and minus, and make sure keep that in brackets at least for now, where you can distribute it right away, and we have a minus e to the 2x minus 1. Okay, and so here all over e to the 2x plus 1 squared. Okay, and here what we have is, well, we've got e to the 2x minus e to the 2x, so those cancel out, and here we're left with 1 minus negative 1, okay, which is just 2. So in the end, we've got 2 times 2, we've got 4 e to the 2x over e to the 2x plus 1 all squared. Okay, now what we have to do is show that this is equal to 1 minus the original function squared. So I'd say the best way to do this is to just actually calculate 1 minus y squared. Okay, so this represents the right-hand side, or sorry, the left-hand side of my equality, that one there. And now let's work on the right-hand side, okay, which is 1 minus y squared, and show that they're equal. Okay, so 1 minus, so y, remember, is this thing here, and the whole thing is squared. So it's e to the 2x minus 1 over e to the 2x plus 1 all squared. Okay, so again, looks like we're going to have a significant amount of algebra to do. We'll take it one step at a time here. So 1 minus. So here what I'm going to do is I'm going to square the numerator in the denominator so I can distribute that exponent. So first I have to do e to the 2x minus 1 all squared. This is just squaring a binomial, but just to, to show all my steps, I'll actually write it out. E to the 2x minus 1 times e to the 2x minus 1 again. Okay, and here e to the 2x plus 1, e to the 2x, again, plus 1. Okay, if you're comfortable just squaring that, I'd say go ahead. But if you have any hesitation, I'd show that extra step. So here we have e to the 2x times e to the 2x. That's just going to be e to the 4x. Okay, here we have e to the 2x, negative e to the 2x minus another e to the 2x, so minus 2 e to the 2x. Now notice here I'm not worrying about the subtraction because I know I'm going to have this whole thing in a fraction. Okay, but normally I'd put brackets around that. Okay, and then here negative 1 times negative 1 is positive 1. Okay, all over. And then here we're going to have something very similar. Okay, we'll have e to the 4x, okay, plus 2 e to the 2x, and again plus 1. Okay, now we notice here the expression that I had, everything is all in one fraction. So that's what I'm going to aim for here, is get everything in one fraction. Okay. So here, this is going to be my common denominator. Okay, so times 1, so I have e to the 4x plus 2e to the 2x plus 1 minus, now here, remember I'm subtracting this whole expression, so make sure you put that in brackets, e to the 4x minus 2e to the 2x plus 1, okay, all over e to the 4x plus 2e to the 2x plus 1, okay, and here in the numerator, well, we've got the e to the 4x cancels that negative e to the 4x there. Here the 1 minus 1, those go. So the only thing I'm left with here is 2 times e to the 2x plus 2e to the 2x, which is 4e to the 2x. And here, we'll take a look at this denominator. Where did this denominator come from? It's basically just the square of e to the 2x plus 1. Okay, that's how we ended up with this denominator here. So I'm just going to rewrite this as e to the 2x plus 1 all squared. And lo and behold, this is exactly what we had for our left-hand side. Okay, so therefore, left-hand side equals right-hand side, and we've proved what we've been asked to prove. Okay, so just a bit of a recap. Number one, they're telling us exactly what needs to be equal. Okay, so made sense to determine each side and show that they're equal to the same thing after simplifying. But again, I just want to remind you of this trick when you're taking a derivative and you have to simplify, especially when you've got, exponential functions. You know that they're going to show up in both of your expressions when you're taking the product rule or quotient rule. So here it really helped out to factor out the common